Have you ever wondered how lightning occurs and how we can survive it? Let's unravel the mystery. Lightning, a fascinating natural phenomenon, is the result of an intense buildup of electrical charges in the atmosphere, which are suddenly released. This dramatic release of energy is what creates that brilliant flash of light and the thunderous clap we often associate with a storm. But did you know there are different types of lightning? We have cloud to ground, which is the most recognized, as it involves a discharge of electricity from a thundercloud to the ground. Then there's cloud to cloud lightning, which occurs between different areas within a cloud. And lastly, intra-cloud lightning, which takes place entirely within a single cloud and may not always be visible from the ground. While lightning is a captivating spectacle, it's also a potentially dangerous event. So how does lightning form in the first place? Well, it's a fascinating process that involves the interaction of various elements within the atmosphere. Let's delve into this electrifying subject. Imagine a thundercloud forming high in the sky. Within this cloud, ice crystals and water droplets are in constant motion, colliding with each other due to the turbulent air currents. These collisions are more than just random events. They play a crucial role in the formation of lightning. As these ice crystals and water droplets collide, they can cause a separation of electrical charges. The lighter ice crystals, when knocked upwards by the air currents, carry a positive charge to the upper parts of the cloud. Meanwhile, the heavier water droplets, falling downwards, contribute to a negative charge at the bottom of the cloud. This separation of charges sets the stage for a dramatic event. The accumulated negative charge at the bottom of the cloud creates an intense electric field which interacts with the positive charges on the ground. Eventually, the electrical difference becomes so great that the air itself breaks down, leading to a sudden discharge of electricity. This is what we see and hear as a bolt of lightning. But why does it flash? Well, the electrical discharge superheats the surrounding air, causing it to glow brightly. This glow is the flash of light we associate with lightning. And the thunder? That's the result of the rapid expansion and contraction of the air around the lightning bolt, creating a sound wave that reaches our ears as a rumbling clap of thunder. Of course, this explanation is a simplification of a complex and still not fully understood process. Scientists continue to study lightning, using advanced tools and techniques to unlock its secrets. But even with what we know so far, it's clear that lightning is a powerful testament to the incredible forces at work in our natural world. It's a complex process, but understanding it helps us appreciate the sheer power of nature even more. So next time you witness a lightning storm, remember the fascinating science behind each brilliant flash and thunderous clap. Now, what should you do if you find yourself in the path of a lightning storm? Well, let's delve into that. Surviving a lightning strike is all about prioritizing your safety. If you're outside and a thunderstorm is brewing, your best bet is to seek shelter. Find a sturdy building or a vehicle with a hardtop. It's vital to remember that taking shelter under trees, near bodies of water, or in open fields could put you at greater risk. But what if you're caught outside with no shelter in sight? It's not an ideal situation, but there are steps you can take. Crouch low on the balls of your feet to minimize contact with the ground and keep a safe distance from potential ground currents. Now let's say you're indoors when a thunderstorm hits. You're not out of the woods yet. It's best to stay clear of windows, doors, and plumbing fixtures. Why, you ask? Lightning can travel through these structures, posing a potential risk. It's also wise to avoid using wired electronic devices and plumbing during a thunderstorm. Unplugging sensitive electronics can protect them from potential power surges caused by lightning strikes. Finally, don't be too quick to venture back outside after a storm. Wait at least 30 minutes after the last clap of thunder before resuming your outdoor activities. Remember, your safety is paramount when it comes to weathering a thunderstorm. So, what have we learned about lightning and how to survive it? We've unmasked the mystery around the captivating yet perilous lightning, understanding its various types like cloud to ground, cloud to cloud, and intra-cloud. We've delved into the complex science behind its formation, involving the build-up and release of electrical charges within clouds. We've also highlighted the crucial safety measures to take during a thunderstorm, both outdoors and indoors. With this knowledge, we can better prepare for and stay safe during thunderstorms, and appreciate the awe-inspiring power of lightning from a safe distance.